Hello, my name is Phineas Ulmishek-Anderson, and today I will be presenting our presentation for DP3 for the product Dry Shoes. I'm a member of Team 3. So I want to start off by going over our mission very briefly. So we wanted to create a device that will dry shoes in a quick and efficient manner in order to help people increase their comfort and productivity on days when it's raining and people have wet shoes and are uncomfortable. So we wanted to help people out so they didn't have to deal with that. In order to do that, we had to come up with some of our customer needs. What would they need from a product like ours? And the result of that was this survey that you see on the screen. It ended up that the most important needs that we identified were obviously, number one, that people want the shoes to be dried, as well as their socks and feet. They wanted it to be energy efficient, compact and mobile, and they wanted it to be easy to clean out afterwards, were some of the big ones. We ended up coming up with these target specifications for our product. A lot of those were focused on just addressing the customer needs. You can see some of them here, but those aren't that important right now, so we're going to move on. From there, we moved on to our concept generation and selection. This was one of the more important stages of our process, as we needed to make sure that we were coming up with viable solutions. So what we ended up choosing to do was a combination of a heat gun with fans to circulate the air and a motion sensor to trigger the device. In terms of intellectual property, we want to make sure that when we're inventing anything new that we are aware of products that already exist. As a result, through the course of our research, we found these two patents for previous shoe dryers. The first shoe dryer had hot air that was vented into the soles and then also was distributed throughout the outside of the shoe. This didn't really have any impact on us in terms of what we could and couldn't do because it was a product designed for a different purpose and there's a different method of heating. So we were in the clear here, but it did provide us with the idea to put a mesh flooring on our own product in order to help with the removal of water and other such things. The second patent over here, hot air was blown down into the item of clothing. This patent was expired, so it really didn't impact our decision-making process at all. But they did have the good idea for the addition of a nozzle, perhaps, to direct the airflow from our fans. And it also included portability as part of the patent, which made us think about the portability of our own device. We went on from there to failure modes and effects analysis of our product. There were a couple of ways we found that could lead to failure, in some cases catastrophic. Most dangerous were issues with overheating. This occurred across a couple of our parts where we were concerned about it. So we came up with the idea to put in temperature detectors and temperature shutoffs if the device goes above a certain temperature. And then another issue was exposed components. We had exposed fans and exposed heating coils, which could cause injury to the user. So we wanted to address that moving forward. Now we've gotten into our design for assembly. This table here shows the breakdown of estimated assembly times for each of our design processes. It took about 83.18 seconds. That was based on the speediest model. It will most likely take longer than that to assemble one entire part. But that is the estimate that we used for calculating approximately how much it would cost to pay somebody to assemble this part for us. Moving on to the design for manufacturing, we discovered that it would be, well, inhibitively expensive to have our parts made out of house. We used Proto Labs to generate quotes for each of our parts, and it was outrageously expensive. It would have costed thousands of dollars to make just one part. So we came to the conclusion that even with scaling effects and bulk discounts, it would not be effective to have parts manufactured out of house. So we decided to move for an in-house approach. That would include the 3D printing of all major components, as well as the manufacturing of the motion sensor and heat guns ourselves, which we're more than capable of doing and would keep costs down. This is our end bill of materials. These are the things that we would need to make our product as it was in our final design. The unit cost ended up being about $150 to build one unit, just based on the material costs. Now we get to the CAD model of our finalized product. I'd like to point out a couple of things to you on here. As you can see, the motion sensor at the back of the device is triggered when somebody places their leg into it. This activates the heat guns and the fans, which begins to circulate the hot air and dry out the shoe. The floor of the CAD model, we slanted it so that all of the water would flow to one side, and then we have an output down at the lower corner. So the floor slants down towards the output so that the water will exit through that output and travel to an external tank where it can be processed and recycled. And this is our final prototype. As you can see, it looks almost exactly like our CAD model. Unfortunately, we ordered a bunch of the parts to be 3D printed, almost the entirety of the product, in fact, but they were not 3D printed in time. So as you can see here, styrofoam for the base and only a few of the heat guns, the motion sensor, and 2 of the fans came in through the 3D printing. But in reality, all of this would be 3D printed. The plastic that we used is resistant to heat, well above the temperature that we would ever have our device at for the safety of the user. So the plastic would not be subject to heat wear, but this is the final product as it came out. And now we move on to analyzing where we should go next with this project. What are the next improvements we should make? And this is what we came up with. A lot of different products have multiple different sizes, they have modifiable parts, and they can be personalized. This might be the direction we want to go with this product, making it possible for people to get their own individualized foot and shoe dryers. We could also install a flat graded floor. So right now our floor is slanted and people must stand on this slanted floor or put their foot on it. This might be uncomfortable for people. People with different types of shoes might not be able to. But if we put a graded or meshed floor in, then people will be able to stand on top of it, and then the same slanted floor can exist beneath that platform, and the water will still be funneled out. Next, of course, was protection of the fans and heat guns. We do not want those exposed in any final product we would send out to people, so we would address that issue. Then also we would have to find out a way to filtrate the water and recycle it. That's part of our environmentally conscious approach to this product. We wanted to find a way if we could maybe reclaim some of that water, but we would have to figure out how to do that. And then the last thing is ventilation. We didn't really address it at all with this project, but we don't want to just have people's nasty shoe water being evaporated out into the surrounding areas. So we would have to find a way to ventilate those areas and remove that air and put it to the outside of these buildings where we want to have our device. But that is Dry Shoes. That is all we have for this semester. Thank you all for listening.